Hello guys, I hope you're doing well. Welcome to my YouTube channel, which is Data Science Gurus. In previous lectures we have discussed about supervised machine learning and the practical application in which I have done the practical implementation of text classification in Python. So today we are going to discuss about the unsupervised machine learning, and later we will have a practical implementation in which I will run the code on the real world data set so that we can actually see that how to implement and how we can use these machine learning algorithms in our daily life routine. So before going to the slides, we can just go through the previous lecture that what actually is machine learning so that we can recall it. What is machine learning? So machine learning is a subfield of an AI, artificial intelligence, that involves the creation of algorithms and statistical models which enables computers to perform a specific task or make a prediction by learning from the data. So basically it's a subfield of AI, involves the creation of algorithms and models and enables computer to perform specific tasks and also the predictions. Key feature of ML, its ability to automatically learn and improve from the experience. So why we need machine learning? Predictive analysis. For example, if you want to predict the Bitcoin price, you can use data from like past 10 years, 12 years, 30 years, or so you can actually give the data as an inputs, and the machine learning algorithm will actually predict the price for next few days, next few hours, next few months. So we can do the predictive analytics or predictive analysis with the help of machine learning. Then things goes for natural language processing. It understands the text classification, a lot of you also know about ChatGPT, LLMs. They also work on natural language processing. Then the third and the main the application of machine learning algorithm are computer vision tasks, in which you can actually do the image recognition, you can do the object identification and image processing as well. So the fourth one is recommender systems. You can do the personalized. You can design a machine learning algorithm for personalized recommendations. You can take the example for Netflix. If you watch a movie, you have some suggestions of the movies that are closely related to that specific ones. If you're doing online shopping, the recommender system actually helps you to it actually recommends you that okay, so if you like this specific product, so probably you're also going to like this one as well. And the last one is about the fraud detection, credit card fraud detection. If you have the data from the bank, so that which has records for the customers, so you're going to design a machine learning algorithm on that, and then you can do the prediction that whether this person is going to do a fraud or not, or you can also use it for loan approval as well. So a lot of applications in our daily life. So we have discussed this thing before. We are just going to recall it. So we have supervised learning. In unsupervised, there are three types: supervised, unsupervised, and reinforcement learning. So machine learning basically have three types: supervised learning, unsupervised, and reinforcement. Supervised learning, basically in supervised learning we have the labeled data set. So the text classification is one of the best example for supervised learning. We actually knows the label inside the data, so it is called a supervised learning. And other ones are unsupervised and reinforcement. Unsupervised, we don't have a label data set, so we have to design a machine learning model that actually extract the features by itself. And reinforcement learning, it basically works on the decisions and also works on the feedbacks. Okay, unsupervised. Today we are going to discuss in detail about unsupervised machine learning, a technique in which models are not supervised. Using training data set, models find the pattern itself and insights from the given data. So real life examples are just like humans. So it actually finds the pattern by itself, and then it works on those patterns. Unsupervised ML, why we need it? So when manual labor is desired, when you're not going to use a manual labor, so inside the training process, when it is difficult to find patterns, and when there is a need to find the hidden pattern. So that's how you're going to use unsupervised machine learning. Okay, so in unsupervised machine learning, we have the two basic types, which are clustering and association. Okay, we are going to discuss in detail. Okay, so the first example is clustering. So clustering algorithms are basically like you can see in this image, we have two type of objects, you can say, or two clusters in this, and they are closely with each other. So we have to make the clusters. So we have to classify them. Okay, so we don't know the labels. Okay, so that's why we are going to use the clustering algorithm, because we don't know the labels. So what actually we are going to give the input to the data. We are going to give the input data to our machine learning model, and then it will exactly like try to find the features and then classify them into two clusters. So here you can see in yellow and in gray color we have two clusters, and on the right side you can see the output for these two clusters. So on the left, this is basically an input, and after passing through the clustering algorithm, it will classify them into two clusters. Okay, so the other type is association. So in association, we are actually linking the things with each other. So for example, if you're going to if a person goes to buy some ingredients or something to cook, or something for the breakfast, so we make association. So in this case, you can see if a person buys the shoes, that person also buys, there are some kind of probability that he's also going to buy the socks. And if a person is going to buy a laptop, then there is an association. There is a chance of there's a probability that he's also going to buy the laptop bag as well. Okay, so in this way we are going to make the association rules with each other. If we take an example for to buy the products online or to buy from the store, if a person is going to buy bread, then there are like good chances that he's also going to buy the milk as well, and there are also chances that he's going to buy the bread as well. Okay, so we make the association in this association rules in this case. So popular algorithms are k-means clustering, hierarchical clustering, a priori association rule, ECLAT algorithm, FP growth algorithm, and anomaly detection. So k-means algorithm. So like in this case, you can see that we have three clusters, so that with different data samples. So in this case, the value of k is equal to 3. Okay, the pros and cons of k-mean. Various applications like customer segmentation, image segmentation, scalable, suitable for large data sets, fast, and it's simple and easy to use. What are the cons? Sensitive to initial choice of centroids, prior knowledge of number of clusters, and limited to linearly separable data, prone to converge into local optima. Okay, the second one is hierarchical clustering. K means clustering, one of the algorithm used for the to do the clusterization. Okay, so hierarchical clustering is one of the is a second type of clustering. So hierarchy of clusters in dendrogram shaped, like you can see in the figure that we are actually clusterizing by we are doing the clustering by hierarchy. Okay, agglomerative approach, like bottom up, each data set is a cluster. In this case, we are considering each data set as a cluster. Divisive approach, top down approach, while a whole data set is a single cluster. So in hierarchical clustering, we have the single and shortest, and it's complete and average and centroid. So in hierarchical clustering, we can actually make the linkages between the two clusters as well. What are the pros and cons? Pros: easy to understand, suitable for small data sets, detection of overlapping clusters, handling different types of distance measures and linkages. What are the cons? Computationally expensive, and different methods give different results, and greedy algorithm, not suitable for large data sets, and when clusters are not well separated. So the third one, now we are going to discuss about the association rules. So it is a priori association algorithm. So it's the second type of unsupervised machine learning. Uses frequent item sets to generate association rules. Designed to work on databases containing transactions. Determines the strong or weak connection between two objects. Iterative in nature. Mainly used for the market-based analysis and drug reaction analysis on the patients. Okay, so what are the terminologies in a priori association algorithm? So antecedent, and the second one is consequent, and the third one is the confidence. Confidence is basically measure of how often B appears in the transaction that also contains the transaction A, and you can see that we are going to write in this way this. So what does it means? So it means that support X equal to the number of times X appeared in any transaction divided by total number of transactions. So here use call for a union, for example, like transaction that have A and B together. So for example, just in case we have like 1000 overall transactions, 200 transactions included the purchase of milk. So the total transactions are 1000, and from 1000 we have 200 transactions that includes the milk, and 150 transactions that include the purchase of bread with milk. So in this way, we are going to make an association rule that if a person is buying milk, then there are good chances that he or she can also buy the bread with the milk. So to calculate the confidence that how often or what is actually the confidence that a person is buying milk, and then he also can buy the bread as well. So how we are going to calculate it? So confidence, like it means that the transactions that are included that include the purchase of bread milk along with milk. So bread with milk, so they are 150. So we have to divide them with total transaction, which are 1000, and after that we can divide the transactions of milk and then the total transactions. So you can, by the calculation, you can get the confidence of 0.75, which means that there's a good probability, or there's a good confidence that we are sure we have a good value, which is 0.75, which means a 75% chances that if a person is going to buy milk, then there's a chance that he is also going to buy the bread. That's how we actually we do the association between the different items. Pros and cons of a priori algorithm. It's scalable, it's simple, and it's widely used. Cons: computationally expensive for large data sets, only suitable for binary data, need high memory to store all the items generated in between. Okay, so unsupervised pros and cons are like no need for the label data, discover hidden patterns, useful in pre-processing of the data. Cons: challenging to know the performance of the algorithm, computationally expensive, and difficult to interpret results. So that's all for today. If you have any question, you can ask in the comment box, and I will also upload this PPT, and in next lecture we are going to discuss about in detail the practical implementation in Python on the data set, so that you can actually have practical example that how these algorithms can be implemented in real life problems. Thank you so much.